All right. I think it's almost 11. Hope you're still fresh just before lunch. Well, I'm not. I had a travel yesterday about 24 hours or so because I'm from the Netherlands. And yesterday when I got to security in New York, it took almost 3 hours and missed my connecting flight to Buffalo. I had to wait for more than 7 hours for the next flight. So.
Well, then, man, let's give him a round of applause for doing that.
Oh, thank you very much. But I'm very honored to be here and to speak in front of you all. And it took the effort to take on your probably free day to learn something new, or maybe to think what you already knew, but take it with you to your home and to your work. So yeah. My mother always said to me, you have to introduce yourself. So this is who I am from when I was born in 1966 until now. I'm from the Netherlands, near to Amsterdam. That's in Western Europe, if you don't know the place. But it's the capital of our country, our small country with 17 million people. We are a highly dense population in the western part of the country. And yeah, well, I like it there. Over there, it's a good country to live in. I also travel a lot, and also in the U.S. I know some cities. I've never been to Buffalo. I took a walk from my hotel this morning to here, so it was very quiet. I wasn't used to this in American cities. Usually it's very crowded and a lot of cars, but in this case it was very easy to walk. These are my contact details, and one thing I would like to give you, and then I skip the commercial talk. I'm authoring a book about CI/CD patterns together with some other authors, and it's expected to come out in autumn. On the side of fact, it says May 2025, but they made some kind of mistake, or they don't have any trust in us as authors, and they say, well, let's extend it until May. Anyhow, we achieved to bring it out in 2024. Well, but that's not the thing I want to discuss for today, although maybe it has some relationships, it all has relationships with each other. Usually when you have commercial talk or talk to the board of directors or whatever you're talking to, these numbers are really good. But if you look at the subtitles underneath it, might be much more worrying about these numbers, because when you look at it, growth rate of malicious supply and attacks has increased a lot, and a lot of these research companies like Gartner and McKinsey discovered and researched over the years, 2022, 2023, that the growth rate of attacks, of supply chain and software supply chain attacks has grown significantly. Another thing is what you see is that boards of directors, they also see the significance of security and doing cybersecurity in a good way, in a proper way. So that's a good thing maybe, but when it comes down to practical implementation or it comes down to money, they already hesitating already again. So, but it's a good thing that's a movement towards that part. And another thing is that software companies or organizations who do something in software or build it, marketing it, they want to have kind of more visibility into what their software is doing in terms of security. So they want to be aware of, am I being compromised in somehow? How can I audit my application? All those kinds of things. They want to get more knowledge and more insights in. So when you look at today's software development, and especially in the open source area, when you fork or any software project and use it for your own purpose, then it might have some risks in it. Your software might be compromised in some way, but there's also already a fix usually on hand. But be aware that the packages which you download, as you can see in this number, can contain malware, for instance. You can see this, for instance, in this picture. Sorry, this one, the crypto miner malware. I think probably you heard of it, or not. But this is some kind of an attack out of the Docker Hub in this case, where in some images there was kind of malware hidden, packaged, and some kind of project downloaded it, used it for its own purpose, and inside, when they got into production, the crypto miner was running without even knowing it. So that's really a bad thing to have. Go back to this one. So for I'm an architect. I'm a little bit into technologies. Over the years you grow over it, and you also look at more like holistic things and things. But I'm an architect, and I'm part of the Dutch government. I'm on some kind of special projects like the Dutch Ministry of Defense for the internal affairs, but I was part of the program of the Dutch Ministry of Defense. And this Dutch Ministry of Defense was building an engineering platform for developers' applications to run it on. And it should have been a private cloud, so no public. It's all air-gapped system, so you can imagine that we don't want to have any public cloud in it. So it was an air-gapped platform, and we had to build a containerized, cloud-native, container-native platform for the Ministry of Defense. The commercial part was that there were kind of software builders in it, inside of a consortium, and this consortium was building all kinds of solutions and solution building blocks. And I was responsible for designing and implementation of the container platform, container infrastructure. There were all kinds of building blocks like security, network, domains with solution building blocks, networking, container platform, CI/CD, all those kinds of solutions, security as well. So it was quite a huge program. So what I was focusing on is to get it also, together with the security building block team, to get it as safe and secure as possible. So we did some kind of an impact analysis on our container landscape and pointed where risks might happen. So first of all, you have your images, the images you use for your containers, for your applications running in these containers. Secondly, your registry, where you store your container images, so your static container images could be a risk. Your orchestrator, so the containers which are scheduled through an orchestrator like Kubernetes, for instance, could be a risk. Or the host where the container orchestration platforms are running. So those are 4 types of risk which you have to consider while designing a platform which is secure, safe, and everything in that order. So these are some of these risks which I mentioned more in detail, like image risks can be vulnerabilities in images. Told you about this the crypto miner thing with malware packaged inside, but also fixes which you don't have applied. So your entire software lifecycle management, configuration issues, anything like that. Untrusted images, so you download something from your Docker Hub, which is not trusted. How do you handle this in this area? So, and registry risks as well. So where you store your images as a static image, not for runtime, but for static. It can also be have vulnerabilities like out of date, insufficient authentication for someone who doesn't need any authentication access it at all. And also these kill chain attacks, which I already showed you in the next slide. So this was, in fact, this crypto miner thing was a kill chain attack. And a kill chain attack is a way of how hackers access your, let me see, oh, I'm now going too fast, just a moment. So this kill chain attack is something how hackers access your systems more in a way which you might don't notice. So first of all, you have this lateral movement, this infiltration thing. They try to pinch in every hole they can find and get in. And you don't notice if you have a good security department, maybe they notice, but usually in this case also this kill chain attack of this crypto mining malware, no one ever discovered it until some point. So this infiltration and lateral movements, they try to discover all kinds of weaknesses in your entire landscape and get the benefit out of it. These are some risks I already mentioned about orchestrators. You can have all kinds of access to it when you're don't have the right to. You don't have permissions, but still it's compromised maybe in terms of access. Mix of different workloads on your containers, while you can do all kinds of segmentations like network segmentation, but also micro-segmentation within container landscape, and micro-segmentation is usually on the namespace level where you apply network policies to isolate the workload from other workloads. But in the most extreme, you also say, well, I want dedicated nodes for this kind of workload. Can be also the case. One thing I had to also address is to make it better and secure is to investigate about secret management. Our security department had some solutions, but it was these building blocks, the solution building blocks were all under isolated stuff, and we had to rely on what they deliver us. But at that time they weren't ready yet. So I had to discover, or I had to investigate more options than only the solutions they had for us. So first of all, secret management. What is secret management actually? Well, secret management is taking care of all the secrets you want to not telling anyone. So secrets can be passwords, can be API keys, can be SSH keys, can be certificates, and you want to store them somewhere in a reliable manner and that it's proper and administered well. So you have to manage them somehow. You don't want to have them sprawl over your entire landscape. You want to, in this case, it's a challenge as well. They can be everywhere in a text file or somewhere where it's public, where no one knows. You don't want that actually. So I already mentioned some common types of secrets. So API keys are they are unique identifiers to authenticate user or a developer or a service to access a certain kind of resource within your application or your container landscape or anything like that. And passwords, everyone knows passwords, of course. They are the most common type of a secret encapsulated somewhere in your application or your infrastructure. SSH keys are a type of secret. SSH keys usually comprise of a public and a private key as well to connect to your terminal, maybe to your Linux environment, for instance, if you need that. And your certificates like SSL or TLS, which you want to also store somewhere, because if anyone can access these, they can access your systems. even when you have something encrypted like a SSL certificate, if they have the public and the private key, then you give them you give everything away and open the door and use it. Now, secrets in container native landscape is also a thing. When you have secrets in Kubernetes, they can be as well API keys, but they also can be tokens, OAuth tokens. And secrets usually, when you run containers in Kubernetes runtime, then they are stored in memory, like the TMPFS file system. They are stored over there. And when they're static, they are stored in a key value store, which is called the etcd store. That's the configuration store for Kubernetes. But actually, you don't want that, because when a hacker anyone who is not allowed to access your system, get in, then they can get all these secrets for you. So various types of secrets I already mentioned. The opaque secrets, which are usually usernames, passwords. Service accounts tokens for more like interfacing with other applications or within your container landscape, containers across each other, interacting with each other. You do usually you're using a service account for that. And to work with secrets, you can use different interfaces. You can use your CLI, your kubectl, for instance, you can use, but also you can use it in your YAML manifest to embed your secret type and anything for your application to connect to with this particular secret. And you can expose them as an environment variable, and you can mount a secret on something which is called the volume. It's stored somewhere as a secret on a volume, which can be accessed by the pod running. So usage of secrets within container landscape can be many types. Use it for container pools. So you have to, when you start up an application or you deploy your application in your container landscape, then it pulls a container, so you have to have a secret for that to pull it from your container registry. Another thing is authenticate your pods to external systems, like you have a pod connecting to a database maybe, so you have to have a secret for your database to access that. Yeah, that's about it. And this is a diagram of how the secrets are stored. Already mentioned, it's stored in memory on a TMPFS file system in memory in this case. So the secrets provide this additional security can be applied to config maps within Kubernetes, and the kubelet, which is a component which handles the lifecycle for scheduling applications in your container landscape. The kubelet makes use of these secrets, and they store them into memory actually. So the nodes can actually send them to the pods, and the pods can give it to the applications running in the containers in this pod. So this is a little bit of the flow of how secrets are published to an application running in a container. Anyway, there are some challenges to manage your secrets properly. So one thing is, where do I store them? Usually you say store them on a central location, not spread everywhere, so you don't have any control over it. You want to store it and have proper access control, have good encryption around it. You want to also distribute your secrets in a proper way within a container, in a CI/CD pipeline, for instance. You want to be aware that your secrets are rotated on a frequent manner. So to reduce risks of being compromised, so when hackers come in, they can maybe guess what's in it. And you don't want to have any unauthorized access. So if you have a tool or a solution which mans your secrets, then you can also apply something like RBAC to it to have proper access for anyone. Well, I don't have anyone to tell what the risks are if you have poor secret management. If secrets are spread anywhere, no one controls them, then you can be compromised, you can have data breaches, you can have disruption in your business continuity, because when an application can access a secret because it's changed, for instance, then your business can run. But also things like a reputation for a business. If a business gets compromised, like you hear almost every week, stolen passwords, stolen credit cards, then it's bad for the reputation for a company. Now, for where I work for, it would be twice as bad, because all the data is highly classified, so you cannot allow anything being stolen or being leaked out. Well, best practices within secret management are, of course, well, these are more or less open doors, but yeah, still you need to consider them when you are in such a large program in which I was part of, that then you know that not everyone realizes this. And decisions around security are usually maybe today a little bit better, but in my experience they're always a little bit behind. First of all, let's focus on how can we develop something good. You don't do the shift left principle of embedding your security already in an early stage of your development. So avoiding hard coding secrets, yeah, well, everyone can imagine that's not good. And centralizing your secrets as well. So with this management of your secrets, then you can centralize anything, have good control and good insights of who is using what in what way. Rotating and restrict access, already mentioned that. And also in your DevOps pipeline, already talked a little bit about DevSecOps and threat modeling and all those topics. But this is also a thing when you're doing CI/CD, then you're more and more out of control, because it's going all automated. Of course, someone who built it knows it, but it's going all more and more automated. So you want to have insight in what's happening in the CI/CD pipeline. When is my application connecting to something, and how can I audit in my pipeline, for instance, and how do I store my secrets again? Same as access. So this is a example of such a CI/CD pipeline using secrets. So you have your development, which uses version control for their code. You have your CI/CD pipeline in here. The CI/CD pipeline pulls secrets from a secret store, from a management system, and then it applies it to a continuous in-pipe deployment. So the deployment embeds the secret from the centralized management system for your secrets. And then you can deploy it to production using the proper way of provisioning your secrets to your applications in production. Using all kinds of stages like Q&A, testing, integrated everything which you always do when you do CI/CD. So for this program, for my part of this program, I had to discover or I had to analyze which kind of solution we should use. So these are the three which I investigated and why. First of all, CyberArk. I didn't investigate these because, yeah, these are also types of secret managers, but they were out of line for us. So the ones I investigated were those three, because we were building this solutions project with a lot of solutions inside, where I already told you I was responsible for the container native landscape, and we also had the security block, and the security block was using a PAM solution from CyberArk. And PAM is actually privileged access management, which has more tools than only secret management, also identity management. So this was the first solution. We thought this is what we need actually, and this is what we're going to use within the program. Thing was that they weren't ready yet. They were still building it, and we were getting ahead of them. So management were already asking, we want to have something in our acceptance environments, we want to have something in our production environment. And we said, this is not ready. So what should we do? Anyway, CyberArk has some tool for secret management, which is called Conjur. And Conjur is a platform to centralize your secret management. It has a strong role-based access control mechanism. It has a good audit trail immutable, so the security department can monitor anything about that, around that. It has automated secret rotation to rotate it on a regular basis, and you can integrate it within any other kind of solution very easily. Well, okay. It really has to take some effort, of course, but it has good integration capabilities. I already told you it was part of the solution building block of security. It's a PAM solution, and this is a little bit about how it would look. So you can see here, the left for you, the container landscape based on OpenShift, where you can see at the right the Conjur solution, the Conjur server, which can be made high availability within a cluster to have more availability around the cluster. If one fails, you have your secrets available for your applications. And at the container side, you have your application, and side of that you have something like a sidecar in your pod, which handles the vault things for your secrets. And this is a little bit about the flow of how Conjur works. So you have your developer or your IT admin operations, which onboards your secrets. Can also be done in your pipeline, of course, if you automate everything. The secret is stored in your Conjur database in a centralized manner, of course. Then you have your policy engine, which decides who has access to what. So you can define all kinds of business or all kinds of rules and policies to define which application and which labels of your application can be accessed in what way. You have authenticators, which manage the real authentication for your application. So that's really the interface in the Conjur agent in the sidecar of your container, which manage the really authentication to your application. And then you have the Conjur audit database with the immutable audit trail. Well, for the sake of the project, this was not yet the option. This is the solution which we had to work to because, yeah, in the end it would be the one. But the other thing was we had to investigate also other options because we also already had to go to something like production. And we did an impact analysis around everything, but still the management said to us, well, we have to deliver something, so we have to find for more solutions in this area. So the thing was, we had a IT operations data pipeline. I don't know if you know what that is, but it's in fact a pipeline for collecting monitoring objects and logs. It was a solution which was built on Kafka bus, so event topics, where all systems could publish their events on topics, and they were sent to an elastic log store and collected over there and doing some analytics around that and everything like that. And what they had in this solution, they had HashiCorp Vault for authentication. So we, from our solution building blocks up, this could be an option for us also to temporarily connect to HashiCorp Vault, to make use of this vault for us as well, and to have a good solution around that. So what I did, I was investigating some capabilities around HashiCorp as well. In fact, when you look at HashiCorp or CyberArk or maybe other solutions in this area, we all kind of similar capabilities. Actually, one is more focused on this, the other is more focused on that. So the thing was that we have the dynamic secrets, for instance, so that's a really good thing that you can request for a secret. The system makes a secret for you, and when it's not needed anymore, it's going to be thrown away. So for temporarily stuff like that. And they have all kinds of interfaces for API key stuff, which puts all the secrets you want to store something somewhere. Also auto locking, leasing and renewal, rotating, everything, all those capabilities are in there too. So this is about how this solution would gonna look like. So if you right, again, you have your, in this case again, OpenShift container platform. You have your master node, your master API, which connects to the Synapse, which is a product of the company which I work for. An API which connected to the HashiCorp Vault and published secrets through the master API with a full sidecar to your application file. This flow need is in Dutch, so you can read it. But I try to explain them how it works and like that. So this is a little bit about the flow of HashiCorp. Again, you have your DevOps or your automated pipeline or your developer, which onboards the secrets in your HashiCorp Vault. It stores the secret in the database, secret database. The policy engine really, in this case, also enforces access to your secrets. The mechanism more or less works the same as in Conjure, with authenticators accessible for your applications in the end. And of course also in a database for auditing, to store your audit logs and let them analyzed by your security team. Anyhow, this was also not an option for us. Why? Because the solution was building to the ITODP, so the data pipeline, was only licensed for that solution. So if we wanted to use that, then it would cost the project or the program a lot more money. And they decided, no, we are not going to do that. Especially when you know when HashiCorp increased all kinds of costs around licensing and everything. We even considered open tofu and all those kinds of stuff which are now bought from HashiCorp. And I don't know, it's part, open bowl, I think it is, I'm not sure. But yeah, it was not an option for us. So in the end, my own team, which I led by that time, came up with sealed secrets, which is a good solution, but on a tight scale actually. So sealed secrets. Well, when you go to travel and you go to the airport, then you can seal your suitcase if you don't want to have anyone interfering when it's everywhere on in the process to the plane or anything to not have anyone break into your suitcase, so you can seal it. This is in case what's happening here as well. So sealing is like putting a seal on it and store it somewhere in your code base, for instance. It can be stored in your code repository, and no one can get behind your secrets in this case. And how does it work? You have your YAML manifest. You create your secret, in this case with username, password, very simple. You have your kubectl to make a real manifest. This is in fact a manifest, and use a tool which is called kubectl. And kubectl can make some kind of a sealing around it. And then you have your sealed secret, and within your Kubernetes cluster you have a controller which holds the private key. And the public key you can store them somewhere in your code repository for your application. The private key is owned by the controller of your sealed solution, so no one can access this secret anyhow. Because you have to decrypt it, of course. So this is a little bit about the flow around that. So in this case, again, the onboarding of the secrets, encrypt the secrets to sealed secrets, have the operator, the controller, which holds the private key, as I mentioned already. And you can also store it on a file system as well if you want, with the driver, the storage container storage interface, mounted as a volume for your application running in a container in a pod. What it doesn't do is that it stores it in a vault, so you have to have a separate interface to store it in a vault. But you can also store it, as I mentioned, in your code repository, because the secret itself doesn't have the private key, so you can't decrypt it. Anyway, for the project's sake, temporarily we chose for that solution, but there's some downsides. You don't have any secret rotation. You can do some form of secret rotation, but that's different than HashiCorp or Conjure uses. So HashiCorp and Conjure really rotate your secrets, and sealed secrets doesn't do that. They renew the seal around the secret, but it also has to be done manually, so you don't have any rotation schedule or whatever. It has to be done manually, or you have to build some solution around that as well. But yeah, it's not an ideal situation. These are some of the key things around the different options I investigated. So when you do it on an enterprise or solution scale, then you might choose for HashiCorp or Conjure. When you have a development team and want to get ahead with your project, then sealed secrets is also a good option for less larger scale. So these are some of the capabilities of the different parts I investigated. Like where you can see that HashiCorp and Conjure has a lot of capabilities around that secret rotation and everything. And yeah, Field Secrets doesn't have that at all. So you have to either build it yourself or think of another solution around that. And last but not least, the differences around CyberArk and HashiCorp are small, but still, when you look at the focus, CyberArk is part of the PAM solution, so it focuses more on identity and access management. And for HashiCorp, it's more like securing your secrets using keys, encryption, and everything. But at the end, they're both good secret management systems. Well, to give you a bonus, right just before your lunch, some key takeaways, some call to actions, which they call them, I don't know. In fact, it's already what I discussed. So monitor your secret access, use your audit logs to be aware of what's happening over there. Automate it, so don't do anything manually anymore. But that's also part of your entire CI/CD, DevOps, DevSecOps, whatever term you might use. Yeah, and do proper secret management.
I have a question for you.
Yeah.
You've done a really good job with the features and comparing and contrasting these two products. Did you experience in your investigation anything related to how they've documented it, supported it, or interactions you've had that might lead you to consider one over the other?
I thought HashiCorp was the best one with documentation. Yeah. And Conjure, yeah, you can see that it's not, it's part of their solution, but still, yeah, it's somehow that I think, yeah, didn't give me a really good feeling sometimes. Sometimes fraction documentation around things and everything like that. So.
Thank you.
Yeah, but as a solution, Conjure is really good, I thought. So this is for me, but if you have any questions, please ask them now. I can answer them for you.
I'm working on an external engagement for a client. They have a web application that I found JWT and hard-coded API in there.
Mm-hmm.
While researching the service that they're using, I didn't see anywhere where it said in the documentation whether or not this key should be exposed. The asset that I can use the API is not in scope. From my point of view, how can I explain to the client that although having this information here might not necessarily cause an issue, it's still probably best practice not to have hard coded in the page source of the web application.
How you can clarify to your customer that you shouldn't have it hard coded.
Yeah. So
what's the case that they wanted actually?
So that's what I kind of want to figure out. So there isn't a lot of documentation on if it should even be exposed like that, or if that's part of the way it's supposed to work. But in my opinion, it gave me a lot of information that I can at least start enumerating surface with. And what would be a better option for them to put it in more of like a secret management thing, or to go with the documentation from their service provider?
I think that's a question easy to answer. From my perspective, I would use secret management thing for that. Never do anything hard coded. Avoid it at the best of your capabilities. Not to advise any hard coding things, because it's also when you change something in your code, this changes too, and it doesn't work anymore like that. Never do that. Or maybe forgotten to take it with you the next time, and then you have it all managed somewhere, encrypted, doesn't matter, system doesn't need to know what's hard-coded underneath it. So, yeah.
Because, in the documentation for the vendor, it doesn't say really anywhere that I can see, unless it's documentation that they have that we need authentication for it. I can see, why they would have that there. So I kind of wanted to figure out how I can practice
Yeah. Yeah, well, I would ask them, is it a special requirement to do it hard-coded or no? I couldn't think of any, actually. Maybe only you think it's easy to do. It spares some time, but yeah, I would tell them all the risks involved within that. No one? Oh.
It sounds like you built out quite private cloud infrastructure. Is that accurate to say?
Yeah.
Why were the big three providers not options? I know it was government information. All three of them have some sort of a defense or government version of their clouds.
I don't think in Western Europe we have that.
Yeah. Okay.
And also, I think a lot of Netherlands doesn't want it actually. Also. We want some kind of sovereignty within that. So not be dependent on any external vendor which is across the ocean, like that. Yeah. And it's highly classified, so a lot of gap systems doesn't mean we don't bring in solutions from companies like Microsoft or any other. That doesn't mean that. For cloud building, we want to chose to do it private. Also because this organization also does, I can't tell too much around that, but they have all kinds of sections which are going on missions, having like a ship, for instance, having its own data center within it, and you know any things like that in it actually. So build it yourself and know what you're doing at the point.
I have a question. For those of us that don't necessarily have all of the Kubernetes experience, what is a good resource for us to start learning that you recommend?
For Kubernetes, you mean?
Correct.
Well, that's a good thing. What I did is I studied, what's this guy's name? It was on, I used the Linux Open, the Linux Foundation, for instance.
Kelsey Hightower?
Yeah, he's the one who did develop Kubernetes. But if you want to have real good learning path, then you should go to the Linux Foundation, which has a lot of courses and around Kubernetes.
Yeah.
But also you have these platforms for learning all kinds of IT-related things. I forgot the name, but I've learned from there a lot. Yeah.
Great. Thank you.
You're welcome. Okay, thank you very much, everyone. Have a good.